Okay, fixed number of trials. So I'm going to say that I'm going to use the spinner. The spinner is spin 4 times. Okay, so this is called fixed number of trials. And we always use n to represent it. So here the n is equal to 4. Okay, now the second criteria. What should you talk about the second criteria? If you look at your textbook, it says if we repeat this experiment in a number of independent trials. What do you mean by independent trials? Yes, the first spin will not affect the second one. The probability of getting certain thing. Okay, so now, what is our success and failure for each trial? So for each trial, the second criteria is for each trial, there are only 2 possible outcomes. Like Bernoulli, am I right? Because it's repeated. So 1, we call it the success. Yeah. And success and the probability of success, we give it as P. And the other outcome is called failure. And the probability of failure is 1 minus P. So in our case here, first of all, we have to define what is the success. So you cannot just say, okay, spin the spinner 4 times. So you have satisfied the first one. The second one, what do you consider as success for this situation? If you look at the book, we are interested in getting a success. So you have to define clearly. Is getting blue. All right, is getting blue. So what is the probability of getting blue? In this case, 3 out of 4. That is your P. All right. So probability of not getting a blue, that is the failure. Okay, so some books, they put it as Q, which is 1 minus P. In our case, is 1 over 4. Okay, so number 3. Now we have to define our variable. So whenever you talk, okay, so you must say that each trial are independent of each other. Okay. So is in this case, will the first spin affect the second one? No. So which means that the probability of getting a blue for each spins is the same. So that is called independent trials. So this means independent trials. Okay, so now what is our variable we want to talk about? So I'm going to define my variable. So after you got all this, so you are going to define your variable X. So here you can write each rounds are independent of each other, which means the probability of success is the same for each trial. Okay, so this 1, 2, 3, these are called the criteria for binomial distribution. So now we want to define the variable for binomial distribution. So every time when you talk about the variable, okay, so now I'm going to define the variable. Every question you must define the variable. So X is the number of success out of n trials. This is general. So our X here is, how do you define X, the variable X? Number of times getting blue out of how many spins? 4 spins. Right, out of 4 spins. Correct, I spell spins, S-P-I-N-S, 4 spins. Okay, got it? Hello? So now we are going to build the probability distribution table for this binomial distribution. Okay. So may I know what are the possible value of X? Correct? 0, 1, 2, 3, 4. Someone is frowning. You don't think I'm writing, I observe one. Okay, why you can, some of you all can straight away tell me is 0, 1, 2, 3, 4. Can you explain? Because you spin 4 times. So every experiment you try, you spin 4 times. So out of the 4 times, maybe all the 4 times you don't get a blue. So that's why you're getting 0 blue. Because X is a number of times getting blue out of 4 spins. So can X be more than 4? No, because you only spin 4 times. You got me? Okay. So now, can I move? Okay, so I'm trying to derive the formula for you now. So now, every time when you read a question for a binomial distribution, first of all, you have to recognize, is there a fixed number of trials? Okay. So these are all very important, one by one. Okay, in each trial, okay, what do you want to talk about? Is it 2 outcomes? If not 2 outcomes, it cannot be binomial. And 1 outcome we consider as a success, depend on how you want to define it. And the opposite one we consider as a failure. So you have to define the success and the failure according to the situation. You cannot say there are 2 outcomes, 1 is success, 1 is failure. For example, this case, if you tell me 1 is success, 1 is failure, I straight away give you 0, because that is a general statement. It must be situational. In this case, we are talking about spinning the spinner, getting a blue or not getting a blue. Getting a blue is a success. I can also put it the other way around, not getting a blue as a success. Depend on how you define. I always define success according to what the question wants. Okay? So then you must recognize what is the variable X that you are talking about. All distribution must have the variable. You have to define the variable. You have to find the possible value of the variable. In this case, we are talking about discrete. So it must be countable. Am I right? Okay, so now. So after that, we are going to build the probability distribution table. For discrete, you can build probability distribution table. For continuous, you will have a function. Okay, so now we are going to build the probability distribution table. May I know what is X in our case here? Hey, I'm asking, I'm not saying what are the possible value of X. I'm saying what is X? Yes, thank you. So 0, 1, 2, 3, 4. So now how to get the probability then? Okay, now, when I say probability of X equal to 0, that means probability that the first one is not a blue, and the second one is also not a blue, and the third time also not a blue, and the fourth time also not a blue. So you didn't get any blue. So I have only one possible outcome of not getting any blue. So n, you must multiply. Correct? I told you, if you have n, you multiply the probability because it is an independent trial. 1, 2, 3, 4. So this will be 1 out of 4. Everyone is 1 out of 4, correct? So I write down there 1 out of 4 to the power of 4. That's it. You understand? That is what it means by X equal to 0. So be very, very patient with me. After I'm going to show you how to use your graphic calculator. Let's get the understanding of it first. Okay, now, If I say probability of X equal to 1, what does that mean? Yeah, any one trial getting a blue out of 4 spin. Am I right? So the situation will be probability of, okay, I'm going to list out the outcome for this case for you. So they are all together. The first one is blue. Second one, no. Third one, no. Fourth one, no. All. First one, no. Second time, yes. Third time, no. Fourth time, no. All. First time, no. Second time, no. Third time, yes, is a blue. And fourth time, no. All. First time, no. Second time, no. Third time, no. Fourth time, yes. So I got how many possible outcomes? Or you put a plus. When you say or, you put a plus. That is how you do for independent trials. Okay, I just write dot, 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 okay? Okay, now, for each one, so the probability will be the same, correct? 3 no, 1 yes. So I will times by 4. And 3 over 4 to the power of 1. And 1 over 4 to the power of 3. Got it? Okay, so now, if every question we are going to list out like that, we are going to go crazy. So bear in mind, what does the first number tell you? Number of ways getting 1 blue out of 4 spins. Am I right in this case? So what does this whole thing represent then? You cannot say probability. You should say probability of one of these outcomes. Right? Every outcome, the probability is the same. So that's why I say it's very important. So the formula comes in this way. I'm going to show you this formula. So this is 4C1. So the first, this is called combination. P to the power of 1. If here is 1. And 1 minus P to the power of 4 minus 1. That is 3. So, are you okay so far? Okay, I give you some time to absorb this first. Now, I'm going to teach you not using the formula, but using GC now. Everyone take out your graphic calculator. Hello, don't talk, please. Focus here. Take out your graphic calculator. Whoever cannot understand you, you just hold on. Okay, do you see the word DISTR in blue? So what you need to do, you need to press second first, then vast. Then scroll down, binom PDF. Do you see? Number 8. Binom PDF. Do you see that? Okay, select that. So it come out, trials. We have 4. Key in 4, please. Probability of success, probability of getting a blue, 3/4. X value, our case here is 1. Paste, answer 0.0469. Hello? Okay, so everyone know how to use. That's why graphic calculator very important, huh? But formula important or not? Important. Okay, I'm going to go back to here. Yeah, so I'm going back to a general situation. Student, look here. So, look. Hello. So every time when we get a binomial distribution, we will define our X. If it's a binomial distribution, we will put BIN. And the first number represents the number of trials. And the second number is the probability of success. For our case here, we will put BIN for 3/4. Clear? This is general. This is the example. So possible value for X, 0, 1, 2, 3, until the last one is N. Our possible value for X will be, this is our variable, getting no blue out of the 4, 1 blue, any blue, 2 blues out of the 4, 3 and 4. All right? So if I want to get probability of X equal to R, our case, X probability of X equal to 2, for example. We have done with 1, correct? So now we will talk about 2. So according to the formula, it will be NCR P to the power R 1 minus P to the power of N minus R. This is the formula. So you have to know the meaning of this. I told you already, it's a number of ways to get R success out of N trials. This is the probability of each outcome for this case. correct? So according to the formula, we will use 4C2 3/4 to the power of 2 and 1/4 to the power of 4 minus 2. The best is use our GC, binom PDF, and P and the R answer. So during the exam or the whatever, I'm not interested in the one. If I ask you to find the probability for certain situation to happen, you just straight away use binom PDF for equal to. Okay, look, whether to write out this or not is your choice. But if this answer is wrong, if it's 2 marks, you totally got. If you got write down that one, at least I can give you 1 mark if you write it correct. So up to you whether you want to take that risk or not. So I let you make your own decision. It's not necessary to write, but should you write, you decide. Hello? Clear? Okay. Got it? So that is what you mean by binomial distribution. First of all, you have to decide whether it is a binomial distribution or not. Okay? All the criteria. Fixed number of trials. For each trials, it must be an independent trials and with only 2 possible outcomes. List out the outcome. Which one you consider as success, which one you consider as failure. And it must be an independent trial, which means that the probability of getting a success for each trial must be the same. Then it can classify as a binomial distribution. It must be, when you explain, it must be situational. Okay, now I'm going to teach you how to build the probability distribution table. Here, without keying in one by one. Okay, now everyone take out your graphic calculator. I'm going to build this table straight away using GC. Okay, go to stack. Edit. Key in L1 as X, 0 until 4. Hurry up, everyone just follow my instruction. You don't disturb your friends. Ready? Key in array 0 to 4. Okay. Put your cursor at L2. You want to put at L3 also can. Put your cursor, make sure your cursor is L2 now. Okay. When your cursor is in L2, yeah, you hold on. Visual. Okay, your cursor, make sure it's in L2. L2 is black. Okay, then you go to second vars. Second vars. VARS. Okay, select binom PDF. Number 9, AA, binom PDF. Okay. X value, trials is 4. P is 3/4. X value, you clever. Yes. Key in L1. Then paste. Everything come up. Very nice, huh? So you can fill in the blank. Then you can find the mean, you can find the standard deviation, you can find a lot of things.